Thanks so much to the organizers for providing the opportunity to present today. There's been a lot of interesting conversation this year about systemic racism and challenges with a lack of diversity in many fields. And ecology is definitely one of those fields. And on a day-to-day basis, I think a lot about how we might change the face of ecology and expand the ecological tent. In a group of papers in a forum that will be published shortly in Ecological Applications, the lead authors of the forum, Bowser and Sid, talk a lot about how the field experience is often cited as a rite of passage in ecology. And if we think about field experiences, there's been a lot of attention, especially on Twitter, that's been given this year to the notion that field experiences oftentimes might not feel like a safe space for many ecologists, especially those facing different types of systemic racism. And there's also the fact that for many people, field science may not be accessible. And so in this Ecological Applications Forum, Ellison et al., which I co-author, we talk about how we might think about expanding the ecological tent with ecological data science, which doesn't require that field rite of passage. And so in reflecting on how we might actually start to expand the ecological tent with data science, and also on the work that I've done for almost a decade at Bryn Mawr College, teaching quantitative ecology at a small liberal arts college, and also as the co-director of the Harvard Forest Summer Research Program in Ecology, I identified some different challenges and solutions that I've come up with to share with you today. So one challenge is just breaking stereotypes of this notion that if we look at Silicon Valley, it's very white male dominated. And this can be challenging for students who want to break into ecological data science if they don't fit that stereotype. So in my courses at Bryn Mawr, I have students do an exercise where they delve into the history of computer science and look to see who the great leaders were. And when they do that, they really start to discover that women and people of color were very prominent in the development of computer science. For instance, Ada Lovelace was the founder of programming. And many of us have heard about the Black women at NASA who really helped push the space race forward through the book and movie Hidden Figures. So that's one challenge, is just breaking that initial stereotype. A second challenge is that many students face challenges with access to resources. And they might have old computers, old laptops that don't have enough RAM or storage space. As we saw with the pandemic, with many of our students, there have been challenges with access to Wi-Fi and broadband, depending on where the students live. And so one way that I've overcome that in the classroom is to have students working with cloud-based servers. So our Studio server is one example. Google's Colaboratory, in which students can use Python, is another one. But having students be able to access software on cloud-based servers means that they don't have to have a really fancy laptop or computer at their fingertips, but as long as they have access to a web browser, they can do the work that they need to do on the server. And these can even operate on an iPhone, so that if you're having kind of Wi-Fi access issues, at least you can be able to access it on your cell phone. A third challenge that is very prominent in many computational ecology classrooms is that students come with a wide range of experiences. Some students may have never programmed in the command line in their entire life. Other students may know multiple languages. And so it can be really difficult to develop a one-size-fits-all curriculum. And one tool that I found that has been very helpful in dealing with the wide range of experiences that students bring to the classrooms is to build a community of practice where students are helping one another to learn how to code. So that you have your students who are very experienced can be in a position where they can teach another student what they know about. And I always tell them that they don't really know what they've done in terms of programming or data science until they've taught it to someone else to fully kind of cognitively understand what they've learned. And that's it. At the Harvard Forest Summer Research Program in Ecology, we'll have just like, you know, coding kind of team-based offices so that students and mentors can work together as they're working through things. At Bryn Mawr College, I oftentimes have a computational learning center associated with my classes, and I hold this in lieu of office hours so students can come and program together. My motto is friends don't let friends program alone. And this is really important when students are first learning because they can get stuck for hours on end with just a simple syntax error. And if someone with a fresh set of eyes comes and looks at their code, they'll just be able to say, oh, you have a comma or a parentheses misplaced here, and then they can move on. So I've found that building this kind of community of practice in the classroom and also just through team science in a summer research experience kind of atmosphere is extremely important. So I'd just like to thank the National Science Foundation, who provides funding for the REU site at Harvard Forest, my colleagues at Harvard Forest who helped me to co-direct the summer program, and also Bryn Mawr College for all of their support. Thank you.